All right, let's get started. We're going to do the Riemann and trapezoidal sums. You'll notice I'm only going to do two with you guys. There actually are four different options here that you're going to see when you guys do the Delta Math Link on your own here in about 10 minutes. There's left Riemann sums, which we're going to do one right now. There's a right Riemann sum. Right? All that means is we're going to change the spot where we draw the rectangle. There's a midpoint one, which hopefully kind of is self-explanatory. You draw it from the midpoint. And then finally, we'll do the second one is the trapezoidal one. I think the trapezoidal one is the toughest one. All right, so let's do this one first. Now, let me show you a couple of things. Let me highlight this. Do you guys see the two numbers here? You see those two numbers? I'll zoom in for you. See those two numbers? Those are called the limits of integration. Those are called the limits of integration. So you have actually already, in this class in December, you actually saw this symbol. Right? I showed you this integration symbol, but did I have any numbers yet? No. So what we did in December was called an indefinite integral, right? Which I had you guys practice. Basically, another way to say that is an antiderivative. So go backwards. Okay, so today I'm going to show you, beginning with some limits of integration, what that means. So what that means is if I look at my curve, between 2 and 6.5, did I mess it up already? No. Between 2 and 6.5, I want you to find the area under that curve. That's what that means. All right, now we're not going to find the exact value today. We will in future classes do that. But I'm going to show you how we can approximate it using rectangles. Okay, so the first thing I want you to do is to find what we call the change in our x, all right, or delta x. All right, so take your limits of integration. Right, in this case, we have 6.5 minus 2. All right, and we're going to divide that by how many subintervals they want us to use. All right, so essentially how many rectangles. All right, so in this case, the problem says to use how many subintervals? 3. So that number will change depending upon what they put in the problem. Okay, so we do this math real quick. What's 6.5 minus 2? 4.5. And what's 4.5 divided by 3? It is 1.5. All right, so when I draw these rectangles, the width of them is going to be 1.5. Okay, so I'm going to use a different color. Pink. All right, so my lower number limit of integration is the number 2. So I'm going to start at 2. What type of Riemann sum do they want me to sketch? A left. Very good. A left. So when I think about this, going from 2, what's 2 plus 1.5? 3.5. Going from 2 to 3.5, which number is on the left? Is it 2 or is it 3.5? 2, right? 2 is on the left. So I'm going to draw my dot. Again, it's just a sketch. Right there, because that is my left endpoint. Now watch when I make my rectangle. So draw the rectangle. And where do I stop? At 3.5. All right, if you want to finish the triangle, or excuse me, the rectangle here. How's everybody doing so far? That's one subinterval. That's one rectangle. How many do I need? 3 total. All right, so that went to 3.5. My next interval is going to be 3.5 to what number? Somebody said it. To 5, right? Because 3.5 plus 1.5 is 5. So which number is on the left? Is it 3.5 or 5? 3.5. So I go to 3.5. Here's that dot. Right? That is my left endpoint for that interval. And I draw the next rectangle.
Wait, what do you put the dot at?
I put the dot there because I want you to think that this is the left endpoint of my rectangle. So it starts from the left. I'll show you once we're done. I can erase it and do the right endpoint if you want to see it. How it would be different. Okay. The last one is going from 5 to 6.5. What is my left endpoint? 5. So put my dot at 5. And we're going until 6.5. Now, I'm hoping after you draw that, right? Again, if I were to shade all those in, you could find the area of those rectangles and add them together. That would be an approximation for this actual area under the curve. Would it be right? No, right? That's why it's an approximation. How would it be wrong? It's too much. Very good, Georgie. I think Dave was saying the same thing. See how there's this amount of area, this amount of area. This one's a little bit better, right? But especially this first one, there's too much, right? So what you're going to click is that this is an over approximation. You won't have to write this in. This will be in that dialog box. It'll have the option for over approximation. Right? It's too high. And why is it too high? What do you notice is happening with our function? What is our function doing? It's decreasing because it's decreasing on this interval. I'm going to pause here. Any questions? Would it be different if it was increasing? Yes. Can I show you the right endpoint? Yes, it would change it. Can I show you the right endpoint? Oh, she just. Yes. So I'm going to erase this. No, what? I'm not going to erase it. I'm going to use a different color. You guys okay if I use a different color? You don't have to do this. You can just watch. Okay, ready? So if this had been the right endpoint, so this one it says left Riemann sum. Now we're doing right Riemann sum. So if you're listening to this, notice that this is not what the problem states. What was my first interval? What was my first subinterval? 2 to 3.5. But what is the right value of that interval? 3.5. So I would actually be going here and drawing this rectangle. Well, I'm going to finish them, yes, but you'll see that it's not going to be enough. So then same thing, my right endpoint would be 5. And then my right endpoint would be 6.5. Pink's trying to win that one. Keeps winning. Okay, there we go. Do you see how the green one is not enough? Right, the green one would only be that. We'd be missing a huge chunk of it right there. So you would write, if it was a right Riemann sum, you would write it be an under approximation because the function is decreasing. Ooh, great question. Okay. Everybody okay with the left and the right? Yeah. You're going to see, Eduardo, your brain is thinking like, hey, can we be better at this? Because that's not very good. Right? Left and right Riemann sums are the worst when it comes to approximation. Okay? So let me show you a better one. The one that I'm going to skip, that I did not put on here, that I think you guys you'll have the least amount of issues with, is the midpoint one. The midpoint one is better. Right? If you use the midpoint of those, it would actually be a little bit better. Okay, so left and right are the worst. Midpoint's a little bit better. Here's your best one. Your best approximation would be the trapezoidal. All right, so that's what we're going to do this one, the trapezoidal. All right, you guys ready? Okay, so same thing. Let's start with finding our delta x. Write down the limits of integration. What is your larger limit of integration? 2 minus the smaller one, 0. And then how many subintervals do they want? It says 4. All right, so I heard somebody say it already. 2 divided by 4 is going to be 0.5. Okay, so I'll try my best again to draw this. This one's a little tougher, and I will say, Eduardo, it's going to be really a lot better. So you're going to be like, ooh, wow, this almost seems like it's right on. It's technically going to be still an approximation. It's not going to be right, but it will be closer. And I think there are some of them better than this one that you'll see that has a larger, see how we're only going from 0 to 2 to go from like 2 to 8 when it goes a little larger. You can see it a little bit better. So some of them will be easier to see than the others. So here we go. Let's make the trapezoid starting at 0. So here's 0, comma, the y value. What's up? Yes, I can. All right. And then what's going to be my next value for my interval? 0.5, which is right here. So it's going to be weird to do it because it's pretty close. It's almost like right on. but this is my first trapezoid. And again, I think this is harder right now because you're doing it by hand. When you guys take out your Chromebooks in a few minutes, it's going to be easier because you're going to actually be able to drag it. Okay, so do the next one. Remember, how many do I need at the end? How many trapezoids? 4. You can probably already see it's looking a lot better, or at least in terms of approximation, it's going to be much closer. And the last one. So I don't think you'll have trouble making the trapezoids. Where I think you'll have the most issue is how to answer the last questions. First off, is this an over or under approximation? That's, I think, the hardest part here, because it is a lot better. Those are the options. I tried to draw it a certain way. I tried to draw it to show you it was actually a little bit over. It's a little bit too much. There's going to be little tiny gaps right here in terms of we're drawing too much. All right, so this is an over approximation. And like I said, there will be some that you do, it'll be easier to see that. If you're having trouble with it, I can come by and help. All right, now here's the curveball. Remember, how did we determine that answer on this first one? What did we put for our reasoning? We put decreasing. So when you do the left and the right Riemann sums, you're going to put increasing or decreasing. But when you do the trapezoids, you're not going to do increasing or decreasing. Remember something else we talked about last semester? Yes, well done. We're going to be talking about concavity, right? Concave up or concave down. So how would you describe? Where are you? There you are. How would you describe this one? So remember thing like pouring water, right? Would the water be holding here? Would you be able to hold the water? Yes, you in theory should be holding water. If you're having trouble with that, you also think about making all those little tiny lines to see what's happening to the slopes of the tangent lines and what's happening with them. They're getting what? They're getting more and more closer to positive, which means this is concave up. All right, so concave up like a cup. Let's go. All right. I'm going to pause here.